All right, so let's run through some of the basic ideas in 1.6 and show you some examples here. So the big idea here is we're trying to figure out how angles relate to each other. So an angle, remember an angle is two rays that have a common endpoint called the vertex, okay? So here we have two angles, one there and one there. These two add up to 90 degrees. We call that complementary. They can be connected like this, or they can be not connected. Here these two are complementary, but they're not connected. Supplementary angles are two positive angles that add up to 180 degrees. Okay, so they can be two angles that are not connected. These 115 plus 65 is 180, or a straight line is 180. So when we see two angles that make a straight line, well, a straight line is 180 degrees. Okay, that's half of a full circle if you think of it as open that way. And so that's going to be supplementary. Supplementary, 180. Complementary, 90. Here these two angles say, hey, you're right. No, you're right. No, you're right, because they like to complement each other, right? They say, no, together we're both right. They're very complementary to each other. Different kind of complement there. All right, so when we say one is a complement of two, that means that they add up to 90. So if we take 90 minus 62 in this case, because we know angle 1 is 62, that's going to give us the measure of angle 2. And that's 28 degrees, okay? If we say something is the supplement of the other, that means it adds up to 180. So if I know these angle 3 and angle 4 are supplements, and I want to find angle 3, I can just take 180 and subtract 47. What's left? Well, that's going to be 133 degrees. Okay, that's the idea there. Okay. Now, here's something actually kind of jumped ahead. It says our linear pair. Well, let me change this. A linear pair means, and we'll find this out in a few minutes, they are supplementary. Okay? Supplementary angles. Turns out that linear pairs are supplementary. In a moment, we'll just talk about linear pairs being two angles that make a straight line. These two angles here are a linear pair. They are supplementary. So here we know these two things are supplementary. Well, whenever we know that and we've got these algebraic expressions, well, that means we can make an equation. The first one, 2x plus 1, that's the measure of the first angle. The second angle is x plus 20. And together, if we add those, they're supplementary. They make 180. Okay? So we can combine like terms. 2x plus x is 3x. 1 plus 20 is 21. And so that equals 180. So combine like terms. Don't start moving things around yet. Now we're going to move things to both sides. Remembering our algebra. Let's get the constant out of there. Subtract 21. 3x equals, this is going to be 159 degrees. And if we divide that by 3, to get rid of that 3 there, that leaves us with our value of x, which is going to be 53 degrees. Now, careful, the question was, what is the measure of angle 1? All right, so the measure of angle 1, well, we've got to plug this back in to figure out what the measure of angle 1 is. So let's plug this into here. And we can come over here, we can say measure of angle 1 is going to be 2 times 53 plus 1. 2 times 53 is 106. 106 plus 1 is 107 degrees. Okay, so the measure of angle 1 equals 107. That M again means the measure of. All right? Adjacent angles is our next type of angle. Adjacent angles are connected. That's all that you really need to know. They're connected. Now, a little more specific, they're connected at a vertex and a side. They share a vertex and a common side here. Okay? So adjacent angles are two angles that share a common side and a common vertex. They have the same vertex. Remember, the vertex is where the angle is connected there. Okay? But they have no common interior points, all right? Anyways, in other words, they don't overlap. So angle 5 and 6 here are adjacent. They're connected at a vertex, and they share a side. These two are not connected, so these are non-adjacent. They are not adjacent. Also, this angle here, let's call that 9, and this angle here, 10, those are not adjacent or non-adjacent. Okay? They share a vertex, but they don't share a side. Got to share a vertex and a side. Okay? So here we want to determine if these angles are complementary, supplementary, or adjacent. That's what we're looking for, okay? Let's find two angles that are complementary. What does complementary mean? Remember, complementary means they add up to 90 degrees. Okay? So find two that add up to 90. Oh, there's two right there. So we've got this angle here, and that is angle FGK. The G has to be in the middle. And then we've got this angle here, and that's GKL. So angle GKL is the other two. These are pairs. So we're looking for angle pairs, GKL. Those would be complementary. Okay? If we're looking for two angles that are supplementary, remember, what does supplementary add to? Supplementary is 180, makes a straight line. Okay, or at least add to 180 total. So which of these two add to 180? Well, looks like 49 and 131. Those add to 180. Okay, so we're talking about angle GKL and angle, let's see, this one over here. How about HGK? Angle HGK. All right. So those would be supplementary. What about adjacent? Now that's our other pair we just learned about. Adjacent means they're connected. Well, those two angles that we just talked about were connected. They share a side, but they don't share a vertex, right? They have different vertices. So we got to find two angles that have a vertex like this, vertex G. So how about that blue angle there and that red angle? Okay, those are adjacent. The red angle HGK and the blue angle F. Let me get my angle symbol. Don't forget your angle symbol in there. FGK. So those are adjacent. They share a vertex and they share a side. Okay, and how about this? Here's a good question. Are KGH, where's KGH? KGH is this one, KGH. And LKG, are those adjacent angles? Well, we kind of already said that they're not because they don't share the same vertex. Okay, they have different vertices. Different vertices. Vertices is plural for vertex. All right. What about FGK and FGH? Are those adjacent? FGK and FGH. Well, similar idea. They're no. In this case, FGK, that's this one, and FGH is this one, all right? So we've got the inside angle, and we've got this whole angle. So those kind of overlap, all right? So no, we can say they overlap. All right, there's one of the sides is inside the other angle. That is technically not an adjacent angle. All right. So that's the idea for adjacent angles. They're connected. Same vertex, same side. They share one, I should say. So here's some problems with some equations. Okay. And so here we've got some complementary angles. Complementary angles means they add up to 180. So, I'm sorry, they add up to 90. Complement means they're both right. They say, you're right. No, you're right. No, you're right. No, we're both right. Right being 90 degrees. All right. So together, they make 90 degrees. So we've got the two angles. And we kind of did one like this a few minutes ago. And they add to 90. All right. That's the idea. So we combine like terms. That's 13x. Negative 2 plus 1 is negative 1. Now we've got to get that 1 to both sides. And 13x equals 91. Finish off with a little divide. So we're just doing algebra here now. Okay. So remember our algebra steps. It's been a while maybe. So x is, we'll come over here, x equals 91 divided by 13. Well, 2 times 13 is 26. And if we work it out, I think this is 7. It is 7. So x is 7. That's the first part. Now we want to find the measures of the angles. So let's plug it in. Angle LMN is going to be 4 times 7 minus 2. That's 28 minus 2. That's 26 degrees. And then angle PQR is going to be 9 times 7 plus 1. 9 times 7 is 63. So it's going to be 64. And you can double check. Those do add to 90. Okay? All right, if we have two angles that are supplementary. Supplementary means they add to 180. So 180 is equal to these two things added up. What two things? Well, 3x plus 17, that's one angle. And the other angle, 1/2 x minus 5. All right. Now this one's a little weird with the 1/2. So a good way to go to solve this is to multiply both sides by 2. In other words, multiply everything by 2 because this 2 is going to get distributed. What happens is we end up with 360, 2 times 180. Distribute this 2 here. We get 6x plus 34. Okay, so we're distributing 6x, 34. 2 times 1/2 is 1x. And 2 times 5 is 10. What we do here is we combine like terms. And so we get 7x. Combine the 34 minus 10. That's going to be 24. And we got 360. Let's get the 24. Get all the constants on one side. Remember that? So that's 336. And last but not least, we can divide this, and let's hope it comes out nice. Well, let's see. 50 actually times 7. 5 times 7 is 35, so 50 times 7 is 350. 57s would be 350. This is 14 away from 350. So that's a couple 7s. So it's going to be x is not 50, but 2 less than 50, 48. All right? So that's the key there, and then we want to find the measures of the angles. So we just plug it back in. Angle EFG is 3 times 48 plus 17. Okay. 3 times 48, that's going to be 240 and 20. No, 120. 144, that is. Plus 17, that's 150, 61. Okay. And then angle, that was the measure of EFG. The measure of LMN is going to be 1/2 times x, which is 48, minus 5. And so it's going to be 24 minus 5. 24 minus 5 is 19 degrees. All right, and double check. Do these add up to 180? Yes, they do. All right. Okay, that's the idea. Okay. So here we've got a funny little drawing. Okay. So these guys here make a straight line. They add up to 180. This is what we call a linear pair. Okay. So here the x plus 2 angle plus the 4x plus 8 has to be 180. Combine like terms. 2 plus 8. Okay. Subtract 10 from both sides. And so 5x equals 170. And if we divide by 5, well, 10 goes into there. 10 goes into 170 17 times. So 5 is going to go into there 34 times. Twice as many. So we found x. Again, we want to find the two angles. So the two angles, if we plug this in here, are 36 degrees. Okay. And then the other one, since they add up to 180, we can just subtract that from 180, 144 degrees. Okay. And if you plug that in there, you'll get 144. All right. Well, that's the idea. All right. I think you're getting it here. You can kind of skip past this if you're getting it. I'll go ahead and work it out. If you want to see more, we've got these two angles, 7x plus 13. Okay, these are veins in a leaf, all right? And so these two angles are supplementary angles. All right? 7x plus 13 is one of them. 25x plus 7 is the other. And those two things add to 180. They're supplementary. Supplementary adds to 180. Go ahead and combine like terms. 13 and the 17. The 7 makes 20. Okay. And then subtract 20. And we get 160. 32x. And we divide by 32. And that's going to be 5. X is 5. The question was not what is x. The question is, what is the measure of the angles? Well, angle 1 and angle 2. So angle 1 is 7 times 5 plus 13. That's this guy right here. Okay. And that's going to give us 35 and 13, which is 48. Angle 2 is going to be 25 times 5 plus 7. That's going to be, what's that, 150? No, it's 125. 125 plus 7 is 132. Double check that. Do those add to 180? Yes, indeed. There they are. So that's how we write equations once we know they are supplementary or complementary, and then we do our algebra to solve it. So one more type of angle pair here. We've got linear pairs. And these are two adjacent angles that are a linear pair. Linear. When they're non-common sides or opposite rays. Basically, they make a straight line, okay? That's the key. Two angles, that make a straight line. Okay, that's the simple definition. Okay, that's all you need to know. So they're connected, they're adjacent, and they make a straight line with two of their sides. So here, angle 1 and 2 are a linear pair. Since they make a straight line, they are supplementary. They add to 180. That's important. Okay? So when we have intersecting lines, we get another type of angle pair. See, 3 and 4, those are a linear pair. 4 and 6 are a linear pair. 5 and 6 are a linear pair. But when we talk about these opposite angles, they are called vertical angles. So two angles are vertical if their sides form opposite rays. Basically, just know that they are opposite angles. When we have two intersecting lines, they are opposite angles. That's the key. All right? So here, angles 3 and 6 are vertical angles. Also, angles 5 and 4 are vertical angles. 5 and 4, okay? So here's 5 right here. 5 is that highlighted angle, and 4 is that highlighted angle. They are opposite of each other. Their sides are opposite, okay? So if we want to identify some linear pairs, so these are pairs, linear pairs. They make a straight line. Well, there's like 1 and 4. Okay, so angle 1 and angle 4. Okay. Are there others? Well, there's also 4 and 5. That makes a straight line. See, together they make this straight line here. Two of their sides are opposite of each other. So we've got angle 4 and angle 5. And then when we're talking vertical angles are opposite of each other. They make two intersecting lines that are opposite. So if we look at 5 here, and then opposite of 5 is angle 1. Notice that those two angles make or are made by intersecting lines. That line right there and that line right there. So we have angle 1 and angle 5. And that's actually the only vertical angles in this drawing. All right? So we can also work with some situations here where we got some information. If we know two angles are a linear pair, that means they are supplementary because they make a straight line. Okay? So here we got a situation. We don't have a drawing, so it's good to draw a drawing while we do this. We know one angle is 5 times the measure of the other. Well, how big is the other angle? Well, the other angle, I don't know, so let's call it x. And we know 1 is 5 times bigger. So we got two angles, x and 5x. Since they're a linear pair, we know something about them. The 5x and the x have to add to 180. All right, so 6x equals 180. And so x is, if we divide by 6, x is 30. Okay? So one angle is 30, and then the 5x angle is 5 times 30, which is 150. Whoops. 150. Okay? All right. That's the idea. Well, if we're talking complementary angles, here that we've got the measure of an angle is twice the measure of its complement. Find the measure of each angle. Well, again, a drawing would be useful. These are complementary angles. So we've got one angle that I don't know, this small angle, but the other one is twice as big. So if this one that I don't know is x, then this guy has to be 2x. And we know they're complementary, so we know they have to add up to 90. See how that works? A drawing helps a lot. Add 2x plus x is 3x. And then we can divide by 3, and x equals 30. So if x equals 30, this angle is 30 degrees, and 2 times 30 is 60 degrees. That's the idea. Okay? So I know it's kind of quick there, but some quick examples about linear and vertical angles that hopefully